So hello, everyone, and welcome to Live Academy, the virtual design learning platform by MEAL Middle East Architecture Lab. My name is Riyad Jokka, and I'll be moderating today's panel under the series Trialogues, where we, throughout this week, have curated a roster of 3 panelists in each panel to open up recorded discussions about the experiences dealing with the current and upcoming challenges due to COVID-19 and its global repercussions. In today's panel, we'll be talking about digital fabrication under COVID. And I'm joining from Dubai, but joining me from London again is Manuel Jiménez García, who is the co-founder of the robotic manufacturing design brand Nagami, based in Avila in Spain, and co-founder and co-director of Automated Architecture Ltd, or AuAr, design tech consultancy based in London. Daghan Cam is also joining us from London, and he's the co-founder and CEO of AI Build, a London-based company developing additive manufacturing hardware and software technologies. AI Build aims to make large-scale additive manufacturing accessible to designers and manufacturers by increasing the level of automation and reducing production costs. Alistair Parvin is systems designer and civic entrepreneur. He's the co-founder of the Open Systems Lab R&D company, developing digital technologies to transform housing, construction, planning, and cities in the 21st century. Their current projects include the Wiki House, Plan X, and Affordable Land. So I'm very excited to hear their perspective on today's objective of this panel. Myself, I'm Riyad Jokka. I'm the founder of Middle East Architecture Network, or MEAN for short, and Middle East Architecture Lab, through which we are organizing a Live Academy and today's Trialogue. And I'd remind you that the objective of this panel is to basically ask the panelists about their experience as the founders of 3 successful startups in architecture technology. We would like to know, how did they incorporate the global changes and challenges due to COVID-19 in their practice? And we'd like to know their plans and actions to turn these challenges into opportunities. So we'll start with a short presentation by each one of the panelists, starting with Manuel. So Manuel, if you could please share your screen and go through your presentation to introduce your work to us.
Thank you so much, Riyad, for the invitation to this very, very interesting debate. And for the introduction. So as Riyad mentioned, one of my multiple hats is being the co-founder and CEO of Nagami, which is focusing on robotic manufacturing, especially 3D printing, to bring products to the market. Products that were not accessible before these technologies started to improve and increase in its actuation scale. So we've developed a large series of products of different types, but mainly focusing on furniture, but as well increasing our scale towards medium or small, medium kind of architectures, and hopefully very soon to go much larger. But the main objective of the company is to take these products out of the gallery setup, the museum where 3D printing was especially limited towards, and take them to the overall public, make them accessible to the people. And that's what our work kind of focuses on and has focused for the last 3 years. So we normally draw this comparison. This is not just essentially to Nagami, but to the opportunities that 3D printing and additive manufacturing bring to us in comparison to, let's say, the previous hit in manufacturing, which was the assembly line created by Ford, right? Which basically allowed the car to become a basic facility for everybody, right? So he narrowed down the production of the cars, making them all identical, and through the manufacturing methods and the production line, made them accessible for everyone to own a car. And that's one of the main reasons why we all have a car. Not all, but most likely it is not as scarce anymore. However, that requires a long and wasteful production chain with all these steps basically engaged in a large production chain that also requires a high initial investment, right? So all these pieces are repeated and especially produced for one model, right? So they require molds and specialized pieces to be produced. And as a result, standardized products, of course. 3D printing comes as a promise for a much lighter production chain, very, very short. There's just one machine and a huge variety, a multiplicity of possible products. It introduced the ability to do on-demand production with zero waste, to not hold the stock, and it introduces customization. So every single product can be different, right? This has large implications, but very, very recently, we have all acknowledged, or the world has acknowledged some of the main advantages of 3D printing and additive distributed manufacturing as a technology that would allow to very, very quickly jump to a complete different product and produce it locally, right? And this is something that perhaps for many people is kind of new and has been evident in this COVID situation. But already 6 years ago, as you see in this article, over 750 million people had access to a 3D printer within 10 miles from their home. So this has already been happening for quite a long time. And now we see how this clicks perfectly in solving a situation very rapidly. So makers from all over the world started to use these machines immediately to produce for the local hospitals, reducing also long-range shipping and therefore also reducing our carbon footprint. We obviously jumped on board with this initiative from the very, very beginning, and we shifted our entire production towards manufacturing these phases. We also discovered, we knew that already, but we started taking advantage of our methods, not for producing beautiful pieces, not for producing eternal variation, but actually to produce much faster than any conventional 3D printer. So we can change our entire production line with the 4 robots that we currently have to produce one face shield every minute. And that was obviously extremely useful for delivering as many products as we can to those in the front lines that were just awaiting for this to arrive and every minute counted. However, even if we've been focusing in furniture until now, this technology obviously has the potential to scale up to much larger structures, to start entering the domain of architecture, applying the same quality that with perfection to the level of furniture, right? And that is a decision that we made at the very beginning, just start testing in very simple, very small pieces, but that have structural requirements that are in a way miniatures of what could become buildings. So this is a sculpture is on the right. I hope it's not covered by everyone's faces as I have in my screen. That's a sculpture that we recently produced with Ross Lovegrove, just printed in one single shot of 48 hours. So essentially, if you imagine the advantages of these distributed manufacturing methods and the scale that we're starting to achieve, we can start not only the world of products, but also the world of architecture. And so the question that we're right now facing, and that I think will be important to discuss in this panel, is if automation and distributed manufacturing technologies can allow to create a complete new market, not only for products, but also for architecture and design. With that, thank you. You can check, I thought I was not allowed to put videos, so now you can check our videos online in our website or in our Instagram, nagami.design. Thank you.
Thanks, Manuel. That was a very thorough presentation of your work. Obviously, we can expand on it for hours, but this was a great introduction. And now we'll move to Dağhan Çam from AI Build, who would basically present also his work with his company that he's founded. So Dağhan, if you can share your screen and share the presentation with us.
Yeah, Riyad, thank you very much for the invitation first, but also for organizing this platform and making it happen. I think it's very important that we are creating these kind of initiatives, which is really good examples of how the new world can become different, but also better in some ways than the old world. So, for example, we wouldn't be able to meet in this kind of context if this unfortunate situation didn't happen. But COVID aside, I would like to talk a little bit about our work at AI Build today and how we are tackling the changes and the challenges coming up. So briefly, AI Build is a London-based company. We started in 2015, and with a team of software and hardware engineers, we are building technology for the factories of the future. And what I mean by the factory of the future is basically factories that are autonomous, cloud connected, and primarily additive. To be a bit more specific, our technology consists of hardware and software components that are currently being used for additive manufacturing in a very wide range of industries, including automotive, aerospace, marine, as well as architecture and design. The hardware component is called AI Maker. It's a large scale, in this case, 2.4 by 2.4 meters, multi-axis 3D printer that can manufacture parts at very high speed and low cost. It's filled with an array of sensors and cameras that are used for real-time control and monitoring, which are very important. But also this thermal enclosure we have around the robot is creating a consistent environment for achieving a consistent print quality, which becomes very important when we are working with industrial materials, engineering-grade materials for industrial applications. On the software side, we have a cloud platform called AI Sync that drives basically these machines. What it does is it takes design files from a CAD package and creates optimized instructions for these machines in an automated way. And then the user can send these instructions to any of their robots from anywhere in the world just by using a simple web browser. One thing we looked very deeply into when we started AI Build was analyzing what makes additive manufacturing so expensive and inefficient compared to more conventional manufacturing methods like injection molding or CNC milling. Because the advantages were kind of obvious to us as architects. You can get to do like very complex shapes in very in short amounts of time, but it doesn't really scale to industrial applications, mainly because of the cost. And we quickly realized the main reason for this high production cost has actually nothing to do with the cost of the machines or the cost of the materials. And we discovered it's only about the cost of human labor that's involved in the process. And so that after it became crystal clear to us that the human labor is holding this technology back from scaling into industrial applications, we became almost obsessed with this level of automation that we can achieve with our technology. And at the moment, it's the primary key metric that we are measuring for improvements of our products, like how many seconds we are spending as humans to get a part from a digital state to a physical product. The ultimate goal here is to reach 100% automation with lights out manufacturing. Of course, we are not fully there yet, but we are constantly making progress in that direction. So this is easier said than done, like full automation and dark factories, but we figured a way that can help us get there in a more efficient way, and that's about autonomy of the robots. So when we look at how conventional 3D printers work, there's usually a fixed design file that comes from a CAD package, and then there's a slicing process that happens on the computer, which creates a G-code file. You would upload it on the 3D printer, and it usually fails. The first trial almost always fails. And then the user goes back, makes some changes to the printer settings, and uploads it again. And maybe it works second time, maybe not. So what we are trying to do with AI Sync and AI Maker is to make that process more streamlined. Basically, taking a design file and not taking human inputs, like minimizing the human input to the bare minimum, in order to reduce the number of possibilities that can go wrong based on the human inputs. And the way it works is basically the design is being analyzed on the cloud with very powerful servers automatically. And then we would create a toolpath. We would actually create thousands of toolpaths on the cloud and then pick the one that we think will perform the best and send that to the user. And then the user would upload this on the printer. And then the second stage of the optimization begins, which is basically when the printer is making the part that it's supposed to do, it's actually looking at what it's doing and it's trying to compare what's happening there with the digital simulation we did in the cloud. And the advantage of that approach is, for example, if we notice some things that are not going right, we can change print parameters on the fly. So for example, in this case, we are looking at the node positions of this lattice and correcting where they are supposed to be. But at the same time, this way we are getting automated quality control. So for example, if a part is failing, the user knows that immediately. So they can either change something or worst case, they can stop the print and restart. Lastly, I want to talk a little bit about the role of architecture in our company and the way we work with architects. It's been very special for us, like coming from an architecture background, me and my co-founder, Michael Desilas. We found a very unique way to make this collaboration mutually beneficial to each side. And I'll try to explain what I mean by that. I actually had 100 more slides, but because of the 5-slide rule, I squeezed everything, as you can see, into this one. But so over the last 5 years, we had the opportunity to work with some of the really good innovative design teams like Zaha Hadid and Arup Engineers, APF in London, Refik Anadol now in LA, and of course the Middle East Architecture Network in Dubai. But so our first thought in these collaborations when we started the company was, okay, we have a strong technology. Let's show it to the architects from our network and ask them to do their projects with it. And it started that way, but quickly it turned into something unexpected, almost in the reverse direction. The architects started inspiring us to improve our technology. So it goes usually like the architect would say something like, yes, that's very cool, but can you also do this, and this? So they really challenge us in a way. And in almost all of these cases, we took that challenge and we tried something that we haven't done before. I can give you so many examples of that, but I think I'm running out of time, so I'll keep some for the discussion later. Thank you.
Yeah, thank you so much, Dağhan, and good to see our pavilion collaboration on your slide there as well. That was a labor of love for sure. So thanks for your hard work and what you're doing and your beautiful presentation that really laid that out. Next up is Alistair, who would present also his work with Open Systems IO and most importantly, WikiHouse as well. So Alistair, can you please share your screen and we'll start with your presentation.
Good afternoon, evening. I think everyone is across the span of afternoon, evening mostly. I didn't see anyone who's in morning, but good morning if I missed someone. Everyone. Yeah, so I'm going to talk, as we mentioned before, our work is bridging a lot of aspects of digital innovation in the built environment, but I'm going to particularly talk about WikiHouse very quickly. Oh, there we go. The question, I guess, or the kind of challenge is probably one that all of you are familiar with, which is that the way that we build, most buildings today, it isn't even in the Fordist mode yet, right? It's still in craft. It's still in craft mode, measured and cut on site, and the implications of that are disastrous in terms of waste, in terms of emissions, even in terms of injuries, et cetera, in pretty much every dimension. The construction industry globally does terribly right now. Particularly buildings are responsible for 40% of all carbon emissions. Now, 28% of that is the operational emissions, which is hard to bring down because it includes existing building stock. But 11% is embodied carbon, right? And now we can make that go. We know how to make that go away very, very quickly, and we're not really doing it. So pretty, certainly wherever possible, in climates and economies where it's possible, it probably involves building with timber, because timber is carbon, what is it, negative. And then also, of course, this is backed by these kind of fragmented and fractured supply chains behind it. So this graph on the right here is actually, what it shows is that at the moment, this is UK public sector data, but every pound or every dollar that's spent on a building right now, only 51 cents makes it into the actual building. Like 49 is just going into these overheads, like just paying people to argue with each other and risk, et cetera, right? So incredibly rubbish underlying systems. So the insight, obviously, that we started from is the same thing that a lot of these other guys have already spoken about, which is the potential to bring in manufacturing, digital design, but also to connect that to the web. And what we saw the ability is once you can write buildings as code, and once you can share design patterns as code, then effectively we could do for the design of built environment what the open source movement did for the design of software, right? Which is rapid acceleration through open source collaboration. So we thought, okay, that's interesting. Let's start exploring that avenue. And oddly enough, our way into this is a little bit different in the sense that where a lot of people have explored very hi-fi approaches to digital manufacturing and additive, because long run that is better. We went for the most lo-fi thing that we possibly could that was already out there, which was particularly CNC machines. And this is a kind of the really key thing here is like, traditionally when people are bringing manufacturing into particularly housing and the built environment, they're talking about the model on the left here, this sort of Ford, Toyota style model, which is millions of pounds worth investment. And sure, this thing can produce houses really, really, really quickly, arguably faster than the world can actually deal with anyway in most procurement systems. Whereas what we saw is the ability to say, well, wait a minute, look at what the web is really good for. Look at Airbnb, look at eBay, look at Wikipedia, right? It's distributed networks of collaborate to compete small businesses operating locally can collectively be a massively effective, if not necessarily the most efficient, industry. And so we said, right, let's try and make a new set of building solutions that's designed for that industry on the right, with the machines that they already have. So that's the kind of whole thing about microfactories. So that instead of needing a few £1 million, you can set one up for a few £1,000. In practice, to make a WikiHouse factory now, actually most of what you need is actually floor area. You need you need to be more than a garage. Basically, you need a kind of 200 meter squared kind of space. Any space can be a shed or a barn or whatever. And you set up a CNC machine in it for relatively low cost. So the idea that you could produce a factory producing sub-assemblies very, very quickly, again, using timber. And then we've gone through, it's all an open source project. Again, it's a sort of cutting the long story short here, over many, many years of collaborations. It's an open source project. There's a Slack community, and it's kind of a mess because we're always trying to catch up and be behind. But there's been so many awesome contributions from architects and engineers around the world. And we're constantly evolving. This is a recent version of the system called WikiHouse Blackbird. We're currently now working on a new one called WikiHouse Skylark, which we're going to be releasing soon. But the idea is to make it crazy, crazy simple. So you don't need craneage. You don't need a lot of scaffolding. You don't need to have a lot of high-tech equipment on site. So literally anybody can set up and so, one guy said that actually the company in this video here, he built his own one in his garden and he liked it so much that he set up a small company. He had no construction experience. He used to be a computer programmer. So people can set up small local businesses building super precise, super high performance homes with carbon zero. And briefly, where we're kind of beginning to look forward, as I say, we're developing that technology. There's going to be a new version of that. We've learned a lot of lessons, and there's going to be a new version of that system getting a new WikiHouse system being released. But a lot of our work is also getting into the design workflows and the procurement systems and those kind of broken, fragmented knowledge processes in the design process. Because just kind of giving these technologies to the existing supply chain, I always say, is a bit like bolting alloy wheels onto a horse and cart. So we're looking at how we can use the web to bring design automation into the web to make tools like this. So this is running in the web browser, and effectively you've got a parametric model which is calculating, it's counting every screw, it's writing your details, it's calculating your carbon impact as you're designing. Because this, obviously for clients, this is the big deal. And I think that is a kind of little glimpse into a huge potentially disruptive domain that can begin to reach beyond just the building technology into the underlying systems behind it. And that's me.
Fantastic, Alistair. It's a really interesting presentation and really great to see how our three panelists are using automation, digital fabrication, and robotics to basically, in one way or another, enhance our world in completely different approaches. So we'll start with the questions now. And the first question is, I'm interested to know, and as also a fellow entrepreneur and a business founder, I'm interested to know about your experiences of how COVID-19 restrictions impacted your business, both financially and logistically. It's a very simple question, straight to the point, and we'll start with that. Maybe we'll start with Alistair, actually, since he presented last.
It wasn't that dramatic, actually, in the sense that a lot of it, oddly enough, we're always trying to push so much that, oddly enough, the lockdown did us a kind of favor in the sense that it gave us a chance to catch up on a bunch of stuff that we'd been really wanting to do. If there was one pattern generally, the nature of our work, obviously I was really, really excited to see and I was writing a lot about the way that 3D printers were it was a perfect example of flexible supply chains and how distributed flexible model outperforms the centralized one. But of course, CNC, doesn't really apply to. Oddly enough, the only pattern that we saw like that was we saw during the first part of lockdown, we saw to some extent a downtick in work from professional organizations like developers and housing associations and councils, and an uptick in the self-builders, right? So people who are stuck at home in lockdown they're like, oh man, I'm going to be working from home now. There's no such thing as the office anymore, so I'm going to build one in my garden. So that was kind of one pattern. But now, of course, where our stuff is probably coming a bit more into its own is in the recovery period, where we're in this huge economic crisis. And so government are asking, okay, how can we respond to this? And of course, green construction is one of the best ways that you can reboot an economy. But of course, there's this massive skills crisis and these obsolete technologies. So a lot of local and national governments are very, very interested in how they can use a distributed supply chains approach to use this kind of, to reboot a green economy in the wake of the crisis.
Yeah, and it's really interesting that you say that, because you basically started the idea of your company with looking at the inefficiencies of the current situation before COVID. And I think that helped you during this crisis, because a lot of the technologies that you've looked at were fully functional during the pandemic, because you didn't need to go to the office to design something. You can just do it on your cloud system. Manuel, what do you think about that? How did Nagami design get impacted with the COVID-19 situation, and how did you feel its implications both logistically and financially on your company?
Yeah, I think, obviously COVID saved the world in many ways, and I think obviously it made it very hard, for everyone working in manufacturing, because projects were going down, right? Things were slowed down, like everything was down. But at the same time, it was infiltrating this kind of very vibrant, positive thoughts for the future. And even if we were struggling, we were also, working around the clock to shift all our methods to something that was way more important than 3D printing any of the chairs that we printed before, right? And we were and we are very excited about what the future will bring, because certainly in COVID, I think COVID is accelerating a change that we saw coming for quite a few years from now. That's why I also put a slide referring to 6 years ago, 3D printing.
Oh, we seem to have lost Manuel. I hope he connects back. But in the meantime, Dağhan, maybe you can share your insight about how the situation affected AI build. I know that you guys are aiming for complete automation and in the process. And one day I'd be able to send my files without even interacting with a human being and do the entire thing over the cloud and get my boxes of building parts shipped to me. But currently, how did COVID-19 impact your business logistically and financially?
Yeah, well, I would say like we almost have this two kind of phases of the business, which are kind of feeding back into each other. One where we collaborate with designers, architects, and we have this factory in London where we do a lot of R&D type projects. That obviously got affected quite sharply with the lockdown. Basically, all projects we had in hand either got postponed, cancelled, whatever. Those are things that were supposed to happen for the Venice Biennale, Milan Design Week, and so on. But on the other side, where the business focuses on the automation and improving the product, that part actually started accelerating in a way because we already had this kind of idea and vision, and product was moving in a direction where we can operate the factory remotely. And this became really, really a critical discussion with all the manufacturers we are talking with now. Everyone started asking, okay, how can we increase productivity and the level of automation. Companies, for example, that were very concerned about cloud technologies in the past before COVID because of privacy, so on. They now started embracing that challenge, and they're saying, okay, how we can benefit from this cloud technology, even the most strict ones, like in the regulated industries. So that side, I would say, is kind of accelerated, and that we see it as like a side benefit of these emergencies. When something unexpected happens, things that are a bit outside the box become feasible solutions to attack those problems in the near term. So the innovation gets a bit faster. So that I would say was the positive side of COVID for us.
The silver lining, yeah. You got to sit back and do some reflection, maybe also improve your R&D in a way, because you're not as busy as usual with clients and client demands. And what was interesting as an outcome is, since we're all friends and we're connected, to see. It was interesting for me to see some of the stuff that you guys have been rolling out during COVID. And from AI Build, you started actually designing and building your own computer chips for robots in a way. Can you elaborate a bit more about that project? And I wonder if it was a COVID project, or was it something that you were already working on and got to finish during the crisis?
Yeah, no, it's a core part of our products. And in a way, like when we started working with additive manufacturing, first we were naive. We thought, okay, we'll create a software that is a bit smarter than the existing one, so we can create freeform toolpaths and so on. But it ended up, we ended up realizing actually we almost have to reinvent everything from scratch, just because the technology is dated back to 1980s, and everything from the machines, the control systems, how the files are transferred between different devices are like so old, and they haven't caught up with the rest of the ideas, the general ideas in Industry 4.0, like devices talking to each other and so on. So the announcement we made post-COVID was G-code is dead, basically, and we have a better way to communicate with the robots. And this works instantaneously. Even if you're off the factory, you can send a print file, connect to the robot, monitor what's happening, and get some real-time feedback. So that obviously reduces the human intervention and the physical being of the workers in the factory. So that was like a good timing, but yeah, it wasn't COVID related. It's a very long-term project.
Well, I hope you give me a cheaper invoice on our next client's design. Would it actually increase the efficiency and reduce the cost in that case if you take away the G code and sort of do it in a faster way?
Yeah, no, definitely. That's the metric we are measuring all the time. Like, what's the failure rate and what's the human intervention needed in terms of seconds? And that's like the learning curve is very steep, and it's like as we approach 100%, it gets more and more expensive to further automate the process. But yeah, we are constantly pushing the boundaries in that direction because that's the way to go.
Fantastic. The next question is about your visions as startup founders. Manuel, welcome back, and host, please unmute Manuel so that he can join us again. It seems like internet in the future home that Manuel has built for himself isn't so good.
Not only internet, the entire electricity in my apartment went down all of a sudden. So
well,
things that happen in the future. I'm back.
I'll be back. I'm glad we got over that glitch. But the next question is about the visions and ideas of your enterprises. So you've started out, setting out the vision, but obviously the future is always uncertain, and now it's even more uncertain. Alistair has touched upon the future financial uncertainties that we're facing. A lot of financial advisors are predicting economic recession. Did your visions for the future, Alistair, sort of shift or pivot at that point where you started reading more about what is anticipated for the near future, and how did that vision kind of adapt to a future that is even more uncertain?
So from our point of view, maybe we're very stubborn. I don't think it adapted. I think we felt more vindicated in terms of the direction we were heading. I think in context of this, I think I'd like to make a couple of points, which is about the future of this space and where this area, because we're really interested. We're interested in changing the industry. That's why we're here, right? We don't mind making money along the way, but that's not why we're here. The first thing I think would be, one of my heroes was the architect Cedric Price, who said, "Technology is the answer, but what was the question?" And most of the barriers, given the systemic crises that we face, most of the barriers between these technologies and the kind of commercial adoption and the social implementation of these technologies that's required, they don't lie in the technology itself, but in the systems beneath, right? The layers of procurement, of finance, of regulation, and particularly in the land system, right? We are still, if you go on Twitter, I just published a piece a couple of days ago about why our land system that we're using in the 21st is actually from the 11th century, and it's completely obsolete and it's killing us. So more and more our attention is focused also on those other layers of the stack. But a related point to that is, this might be a very blunt, straightforward point, which is there needs to be more women, right? Look, we're all men here. Mm-hmm. And there's a problem with that. This is not just an ethical problem, because it's a smarts problem, right? It means you're only having 50% of the smarts are in the room. But B, let's face it, as guys, one of our tendencies, this connects to the previous point, because one of our tendencies, I don't want to be kind of assigning gender stereotypes, but one of our tendencies as guys is we tend to focus on the highly technical aspects. And actually the stuff that really breaks through actually comes from thinking not just about the answer, but also about the question. So there's a whole tier of intelligence that's missing if we're sustaining conversations like this, where 50% of the smarts are absent. So I'd be particularly interested, perhaps when we open up to the audience, to hear from some of the women who are in this conversation as well, and what their view is on the vision and the future of this space.
Absolutely, and actually that's a very fair point that I'm aware of as well. And on our program, Trialogues, I try to have an equal presence of women and men to join the conversation. So the next panel would be all women. So you should join that one as well, Alistair. But I'll go to maybe Manuel to answer the same question. In your opinion, how did your visions and ideas pivot? What kind of new ideas came to mind to focus on the positive change for a better future through Nagami design? and through your other ventures as well. And how did your visions adapt to a future that is even more uncertain?
Yeah, I think as I was actually mentioning before disappearing, right, abruptly, I think COVID is accelerating lots of ideas that were there, they were latent, and we were pushing for them to be adopted, and now all of a sudden they become acknowledged, right? Like one of the items that was kind of impossible to buy during the first weeks of quarantine was, I mean, apart from HoloLenses, that was impossible, right? Entertainment, but it was 3D printers, right? So people are starting to really engage with this, and we're receiving a lot of attention on actually coming with ideas that, well, but could you actually do something to, for example, integrate social distancing in new products, right? We've been kind of framing our products as a new nature that could emerge only thanks for this technology. Mm-hmm. I think events like this are kind of reinforcing that idea that we need to rediscover design with automation and with technology, right? Mm-hmm. And I think this is by opening this up to the entire kind of design community, mm-hmm. and tech savvy, of course. Mm-hmm. I think we are establishing a question of, what will design be if we have new parameters, mm-hmm. that we respond to, right? And we have new tools to play with. So, mm-hmm. so we're now working on very interesting initiatives, actually, for, I don't even want to call it furniture or architecture. I don't really know what they are, but they are really taking advantage of what the technology that we've been developing can allow you to produce, mm-hmm. and rethinking completely design of products upside down. So that is exciting, and I think that's going to happen much more as people will enter themselves much more in the world of manufacturing, as productions will start to shift, right, from a centralized model that we all of a sudden now we see it failing, right? And the conversations around distributed manufacturing is, Alistair was framing them very well. They've been kind of a little bit undercover until now, and now they will start to emerge as real industrial models, and that is exciting. That's exciting for designers. That's exciting for users. And that's exciting for developing this technology to the new level. So I'm very positive about the future. Yeah. So even if this is going to be a very rough patch that will generate a plethora of ideas that will materialize much faster than if that batch wouldn't have existed.
Mm-hmm. Mm-hmm. And I mean, it's obvious that, when I first saw your PPE project, Manuel, I thought to myself, my first idea to myself was, not in a million years would I have thought that Nagami Design would be producing PPE protective gear. But, obviously that pivot was very important, and it was a project that addressed a very important issue, especially in Spain, which was very badly hit with COVID. So it's great to see companies that are involved with such bespoke design that is obviously, attractive for a certain clientele, also to do good projects, so to speak, that are, much more widely distributed, let's say, and cause change at a much bigger level. So that was really great to see. Daghan, can you touch upon your ideas to basically adapt your visions of how AI build would change the future somehow, in a future that is even more uncertain?
Yeah, I think, well, one thing we started seeing with COVID and all these challenges is first, the life started slowing down a little bit. Like just before COVID, you remember we did this pavilion in Dubai, and the way that happened was Riyadh came to London and he says, yeah, we have this amazing project idea. Can you do this? I say, yes, of course, why not? But then he said, yeah, but there's also one more thing I need to tell you, that this whole pavilion needs to be ready next week, like in 10 days. And we hate to say no, so I said yes, and we said, okay, we will put 5 robots or whatever we can to make that project happen. And I said, okay, give us the design files and we'll have a look and make it. And Riyad said, oh, well, we don't have the design yet. Our design is on the plane. I'll do the final adjustments and then send it to you. He said, okay. And then after the flight back to Dubai, Riyad sends the CAD package and he says, oh, by the way, I had to make it 50% bigger. So it was really like deadline after deadline, like pushing us to the extreme, to the maximum capacity of our production. And we never had the time to like go back and think about the bigger picture and ask the bigger questions that are more important for the long term. So that really helped, I think. The silence periods, like 3-4 weeks, we were in lockdown, the factory was shut. And we started asking the big questions. Where are we going? What is manufacturing going to look like in 10 years from now? 5 years from now, post-COVID? We seriously started analyzing this. Like this was our main topic at AI Build. The whole team was like brainstorming so hard. And we came up with ideas that we think we can help with the current situation. And that in a way, like we always see it from the positive side. I think that's the almost a feature of the entrepreneurs. You can never be negative. You have to make the maximum of every situation. So that kind of accelerated certain developments of our technology and product. And that's the direction we are going at now.
Very interesting.
In summary, it's about like more automation, increased automation and dark factories in the long term. But also what we started doing more often after this period is collaborating with other industrial partners. So after like 3, 4, 5 years of developing the product, we started joining forces with other companies that have more experience than us in certain fields and really thinking about the factory of the future in a different way.
Very interesting. And that attitude is exactly why we work so well together at Dağhan. So, it was a really great experience working with you on that project. The next question, and Alistair, I'm not sure if you still have to leave in like 7 minutes, or can you stay with us?
I'm okay at the moment.
Okay, great. So I'll go through the questions with a bit more ease because I'm keeping time here. So your companies deploy advanced technologies both in software development and manufacturing. Alistair, you've showed a great example of how your cloud system, the parametric design system, where people could go log on online and design almost their future home, or you said also their future extension office in their backyard, and so on. I think that's a fantastic idea. And specifically in light of the current situation, as you have also hinted, if this kind of backyard or shed office would not cost too much, a lot of more people would consider it, and also might consider it as an alternative for an office, especially that now we've been put in a situation where for the past 3 months, a lot of us have been working from home, and we figured out that that's not so bad after all. It might be even more efficient in many ways. With the technology that you're using both in software development and manufacturing, how do you think these tools would help us solve our problems in this current and near future? And I mean, I'd like you to hint more about the changing social behavior, if you can. I mean, obviously, the house as a typology might hypothetically see more demand because people are staying at home more often instead of staying in an apartment. If you could provide a cheaper house, then maybe more people would consider it. What are your thoughts on that?
So, by the way, I apologize in advance because my deadline was my son appearing, and so he may appear. He may just turn up at any moment.
Okay.
So I mean, on the face of it, there's the kind of straightforward costs, the kind of cost balances, and I think like any R&D project, right? We work in a slightly different way because unlike doing a huge, big VC capital backed R&D project, and what we've been doing, this is kind of slow, open, and agile with the community, so it's kind of slower. But the same basic rule applies, which is that slowly we've been developing a product that's just a bit more, a system that's more cost effective and so on and so forth, easier to use. And hi. Do you want to come and wave to everyone? Hi, this is my son. We're getting there to a certain point with that. Actually, kind of what's happening is that weirdly, the cost of old systems is going up. So it's kind of like history is coming to meet us in that regard. So we're getting pretty close now to a point where it's cost equivalent, especially for those smaller projects where people can build it themselves because they can do the labor component for themselves, just like an IKEA kit, basically. So in terms of the straightforward mathematical equation of that, that's it. But the bigger thing, and that's why we're so interested in the web, is like, well, why, running a piece of code on your own in an office is to kind of only do a small part of the story. Because if you look at platforms like Uber or whatever, why does Uber work? Uber works because it's a communication intermediary, right? Before Uber came along, we had to phone up and speak to a human who probably had a computer in their office, and they would tell us what was on the computer, right? And the built environment is the equivalent of that today, where, I imagine there's a lot of architects here or budding architects. One of the main experiences you have as an architect is that you sort of go, your client calls up and your first question is, how much money have you got? And your client's first question is, how much money do I need? Right? There's this kind of communication breakdown because the knowledge is all in people's heads. Yeah. So, and this is the power of the web, is that we can get knowledge and data into algorithms and then put those out in the interface. So the web is acting as a communication intermediary. So suddenly in the course of a day, we can communicate with 100 people without talking to them. Mm-hmm. And they can get the information they want from a little parametric configurator instead of working it through with loads and loads of people. So that's why we think the web is the really crucial thing, not just the automation technology itself, but the use of that automation technology as a trust and communication interface. And that, of course, is the really great disruptive thing about the web. And it's why it's been so disruptive in other domains. It just hasn't done that thing for construction and design yet.
Mm-hmm. Just out of curiosity, per square meter, a wiki house, how long would it take to construct a wiki house per square meter? Do you have that calculation off the top of your head? In terms of the time of putting the kit together, Alistair, you're muted again. Host, please, can you?
So of course the answer is it depends. Obviously the assembly time is very, very quickly. The key constraint is the manufacturing time. So generally speaking, in the current system, which is that if you take your square meterage and multiply it by 6, and that's how many sheets of plywood you need, then you can multiply that number by the time on the machine, the cost per sheet of machining. And the cost per material. So typically in the UK, we can get a sheet of plywood or OSB for around £20-25. And then typically the cutting cost out, just put it out now, is about £20 per sheet. So we usually talk about £45 to £50 for that, for that thing. So you can kind of get a handle on sort of where that roughly leads you. The key thing is, in the time constraint, obviously, we're always interested. There is no perfect position, right? You're always just sort of trying to find a kind of balanced optimum between the different constraints. And so you say you can assemble them pretty quickly. But of course, the interesting thing about the distributed network is that, a bit like the example that Dan was talking about, is that if, let's say, so right now for a typical house, it's probably going to cost about 3 or 4 weeks for a single CNC machine to cut it, right? So it's quite slow. Now, of course, you can organically scale pretty quickly because just like 3D printer farms, you just put 2 machines next to each other or 3 machines. And that's how most of the SMEs actually scale, much more flexibly than big factories because they just buy another machine. But of course, the really cool thing is the collaborate to compete network effect. So, we've had quite a few situations. I'm particularly thinking of one. We were making a prototype and we needed the prototype a bit like your story. We needed the prototype in a week, but the house was going to cost 3 weeks. And we're like, well, that's no problem. We just divvy the files into 3, send them to 3 manufacturers and just give them a delivery date. And on that date, three vans turn up on the site and all the parts just slot together perfectly. So that's what I mean by it's about coordination between SMEs. So, and about this ability for a network to collectively do this collaborate to compete thing with the same kind of effectiveness as a big centralized company.
Mm-hmm. Absolutely. And just like our story, we couldn't have done it without our partners, AI Build. as part of our network as well. And I'm looking forward also to collaborate in the future, Alistair. Maybe we can find a way to do that here in the Middle East or abroad. So Dağhan, and the next question is going out to you. What kind of future or current projects are you working on? Can you expand a bit more about your current projects that you're working on for, let's say, this year, end of this year, and the beginning of next year to face the economic recession and the implications of COVID-19. Also taking into consideration that there might be another possibility of another way. I don't want to be a naysayer, but it might be a possibility. From the learning experiences that you've had, what are your current and future projects under the current and future situations?
Yeah, I think one thing that started picking up since maybe a couple of weeks ago after easing down, like in London now it's a bit less restricted in terms of social distancing and so on. Mm-hmm. But one thing that started happening again is these collaborations coming back. So we started discussing new project ideas, new collaborations, new architects. Mm-hmm. So that is definitely going to continue happening in the medium term. I would say we have some exciting projects coming up around Christmas. But beyond that, we started investing a lot of our resources into partnerships and the web technology that Alistair was talking about. Mm-hmm. And for us, web is really like the essential part of what we are doing because of the reasons Alistair mentioned, but also this open ecosystem goes two ways. Like it's on the user side. You can control robots from wherever you are, but also on the back end, the way web is built is around services. So we couldn't have built AI Sync if it was a web desktop application without communicating with all the other services that we need to communicate with. So that I think is going to be the future for us. Like we will be investing a lot into building these microservices that are happening on the cloud, and bringing them to the factory and automate further the manufacturing process. And one thing that's going to happen more often than pre-COVID is going to be more partnerships, I would say. Obviously these are now confidential, but that's the hint for the future from AI Group.
Partnerships with design consultancies or partnerships with bigger companies to develop your technology?
Technology partnerships like software and hardware.
Amazing. So one day I might be able to just go on a cloud system and kind of get an estimate right away, a quotation on how much per cubic volume of 3D printed design. With
you can actually get it like right away. We have an API. You can send a request and it will tell you like it will take you this much and this much money and so on.
Okay, that's really great. Manuel, you've collaborated with Parley on a recent project, and that was a really interesting one. Can you expand a bit more about that project and where do you see it going in the future? Do you see any development of that project in the future, or similar also collaborations with like-minded companies? And you'd have to unmute your mic first.
There you go. Now I'm unmuted. Yes, actually, I think for us also partnerships is a very important part of our business and our future, and especially linked to sustainability. Right? So it was very important for us not just to do the project with Parley, but becoming part of the network. So right now we have a more global partnership. So we're expecting to launch a new series of products, but also larger initiatives to deal with the sustainability in new different ways. Right? So one of the things that is very interesting from Parley, right, as a worldwide organization with the main purpose of saving the oceans, right, is they have this distributed network of volunteers and workers collecting plastic for upcycling, right? And they have kind of their own workflows to then deliver that practice to their partners, such as Adidas, for example. Like Adidas is increasing the use of recycled plastic to the point to, I think they committed to by 2024 have like a 90% recycled plastic coming off for the oceans. So we're kind of increasing its use in our methods, but furthermore and more interestingly, we're trying to start kind of establishing these symbiotic relationships between distributed manufacturing and distributing plastic upcycling, right? To start kind of completing the cycle. So, I mean, obviously, plastic is a topic for discussion for an entire panel, right? I've always said, kind of semi-provocatively, that actually plastic is the material of the future, just because it's an unlimited source that we will have forever, unfortunately, right? And it's there, and it's still only 10% of plastic produced per year is recycled, which is striking, right? So I think if we would manage to establish a very smooth, decentralized workflow on how to deal with this material that we're stuck with for the rest of our lives and the lives of the planet, and transform it into beautiful and useful products, I think that's a mission, right? So rather than a project, I think this is becoming a mission of the company. So we're working now on establishing new extrusion methods as well to deal more massively with recycling. We're also establishing new kind of cycles of recycling our own products, and also see if this material and these methods could be applied to larger projects. So we have a few larger structures coming out very, very soon that are really revolving around this idea. And I think also because, like COVID, I think it's a step on the way, but there is a much longer fight to fight, right? Which is that we are still destroying our planet, even if we just left it breathing for a few months and we could see dolphins in Venice. We should not come back to the way we were. And I think if something positive out of this as well is our thoughts about technology and how automation, as Alistair was describing it very well, I think automation is the key for advancing in many ways towards the future. It is also the key for advancing towards a more sustainable future. And that is for us, I think, a main purpose.
Very interesting. Alistair, what new products are you launching through your Open Systems Lab, whether for WikiHouse, PlanX, or Affordable Land? What kind of new ideas are coming out to tackle this, current and future of the situation that we're living in right now?
Yeah, so we've got some stuff that's a bit of a longer way off, and there's some stuff that's nearer. Obviously, the nearer stuff is that we're going to be releasing a whole bunch of stuff, as I said, for WikiHouse Skylark, which is just a little bit, oddly enough, simpler. Mm-hmm. Weirdly, the deeper we've gone into parametrics, the more we've learned to make a system that relies on it less. Mm-hmm. That will happen at some point, reasonably soon. Our general thing is we open source it. So we open source it as early as possible. But the caveat with hardware is that even with disclaimers on it, we want to have a bit of structural sense checking with the structural engineers before we put files online. So that even though, of course, if people use those files, it's their responsibility. We want to make sure that we're being, it's reasonably possible to use them in a sensible way. So that's happening. Another big thing we're working on is PlanX. So PlanX is basically it's a system for turning planning regulations and planning policies into code, into machine readable code, and baking those into planning services. So obviously the thing that led us into that was we were playing with these 3D things and we're like, well, wait a minute, this should be checking itself automatically against regulations. The actual MVP of that we're working on with a bunch of councils and local governments in the UK is a little bit simpler than that. Although that will be possible in the not too distant future, the fancy 3D thing. The first step is have that information there and have it out there on an API. So, and that's kind of our whole modus operandi is we see a big future, we see a big system, and then we work out what's the smallest version of that system that somebody needs now. And let's build a commercial model around that. And so those are the two immediate things. More long term, as I said, there's the work that we're doing on what we call BuildX, because we're not very imaginative on names, which is the parametric building configurator stuff. Yeah. And then the long run thing is a project called Fairhold, which is actually a new form of land ownership backed by digital contracts.
Mm. I like names that are straightforward and non-imaginative, to be honest with you. So, as you can see, Live Academy, can't get more straightforward than that. But yeah, I mean, we'll keep it a bit shorter, and we've got maybe 19 more minutes to go. So my last question is very brief. We'll start with Dağhan, maybe. What are 3 words that describe the future for you, Dağhan?
Yeah, I think I put it in my first slide. It's going to be autonomous, connected, and additive.
Amazing. Manuel, 3 words that describe the future for you before we take Q&A from the audience.
Yeah, I would say, I normally say automation is a design problem, but I think that's one more word. So I would say automation, generosity, and collectiveness.
Amazing. And Alastair?
Yeah, I'm going to be pretty predictable. Open, distributed, circular.
Great. So maybe that's a good point to start taking questions from the audience. And to our audience and everyone attending, if you'd like to post a question, please post it in the chat. We have these incredible panelists with us today, and this is your chance to ask them a question. We already have a question here, but one more thing. If you'd like to post the question on the chat, I'll read it out to them. And if you'd like to ask the question on video, you can also get unmuted and ask that question. So you can maybe raise your hand and we will do that for you. But the first question that we find here from Aditi. Aditi is saying the efforts to make the manufacturing process more efficient and remotely accessible through robotics is amazing. The conversation touched upon how we can reduce the physical human intervention in the whole process, but in the face of an economic crisis, this idea might affect negatively to the professionals whose income actually depend on the needs of the human resources for a manufacturing process. Kindly share your thoughts on that if we have some time. So I think what he's hinting at is that maybe at this point in time, automation in construction might be the more expensive choice for a lot of working professionals. If I understood that question correctly.
I think it's also referring to people basically being substituted by robots. Right?
Sorry, I apologize. I think what he's referring to is that basically automation in a way would take away jobs from people. What are your thoughts? What are your thoughts on that?
Yeah, I can chip in. I think technological advances always didn't take jobs from people, but they reformulated them and redesigned them. And automation is just one step forward in that chain of evolution. Like when the fire was created, then there was also jobs that were kind of put on hold, and those people started to advance their technology in other areas. The washing machine liberated an entire generation to then start dedicating their time towards developing their mind and again contributing to evolution. I think automation is gonna free us from many of our chains and industrial chains. It's gonna create a much safer, faster, and in the long run more economical industry, and it's gonna allow lots of different kind of jobs to be created as a result from that will contribute to a faster evolution of humanity. So I wouldn't be worried about losing my job because part of the production chain where I work is automated, but I will be excited about the prospects of how I can contribute to that evolution after I don't need to spend my time in such a mechanical job. Someone very interesting for this, I think, is our colleague Mustafa, who created a robot automata, right? That is literally kind of taking that job, right? Is getting a very repetitive task that could be automated easily and simply. And he's monitoring the change of the character and the notion of the job of those people who used to fall deserts and so on. And now they are actually programming robots to do that for them. None of them actually lost their jobs. They are reformulating their professional life. And I think that is an exciting opportunity.
Yeah, I would also totally agree with that. Like, this is a question that always comes, like when we talk about the factory of the future and no humans working on it and so on. But I think we cannot really think about technology in an isolated way from politics and policy making and economy and so on. So I think one thing we need to do now immediately is question also about what does it mean to work and what's the future of work as well as the future of manufacturing. Because it really doesn't make sense for anyone to do a mundane task if there's a more efficient way to do it. Just for that person to, to make a living out of it. Because once you have automation, basically what you are doing is, yes, some jobs are being replaced, but the same amount of value is still being created. Now we need to think about how we can redistribute that value in a more fair way. So I don't know, at the moment in the UK, for example, one thing that's under discussion seriously is 4-day working weeks. Maybe the future of work will be less formal, like going to work kind of commitments, but more flexibility and more creativity. Yeah.
Very interesting.
So I think we should see it from a positive way, because technology is like a snowball. Once it works and it brings value, I cannot see anything stopping it. It wouldn't be wise to resist, but we should learn to work with it and rethink of new ways of living and working. For example, universal basic income also is become a discussion. If that can help people who are being so massively unemployed with these restrictions. Obviously, these are going to take a while. Like they are very big political decisions and will have huge economic impacts. But now is the time to make some fundamental questions and shifts, I think.
So we've got a couple more questions here to go through. So I'll start with the next one from Asma, who's asking, in your opinion, what changes should happen in the current models of architectural education in order to adapt to the requirements of the future? So how, that could have been a question maybe better asked for our previous panelists, but I think also, Manuel, you could address that question since you're also teaching in a way.
Yes, we're obviously having a lot of those conversations at the Barlet where I work and run one of the programs, architectural computation. But to be honest, again, I think it's been an acceleration of those conversations. We've been talking about that for a while. Actually, right now you are in an initiative for the future of education, right? And I think like this Life Academy is a model that could have appeared and emerged before, and then now it just became urgent to be presented as an alternative because people want to learn, people want to develop skills, right? Like we do have this hunger for growing as professionals and as thinkers, and obviously as well as educators. So. Right now, obviously, with the current restrictions, we are rethinking the way we teach. Obviously, we're teaching online, but I think beyond that, what part of that could be distributed, what part of that is a GitHub repository of knowledge, right? And we're also rethinking the way we test, we prototype, trying to make use, for example, of distributed manufacturing technology. So right now, like some of the questions around prototyping, and our course is very massively, heavily based on manufacturing, and there is all kind of really novel ideas making use of a global network rather than a centralized workshop as we understand it was. So I think somehow, like models like the ones that have been presented today, like Alistair's WikiHouse, now they can become a much more powerful approach for people to collaborate across the world and to test their ideas physically. So I think education is being saved. But again, this new model had to exist before. I think the institutional model on this class with certain amount of people and exams and so on, and needed to be reformulated. And this is just again reformulating. We kind of accelerating that process. So it will. I want to see more initiatives like yours, Riyad, kind of increasingly getting attention, traction, and being a big participant in the distribution of knowledge and ideas.
Thanks. I mean, it was an experiment for us the past month, and it was a very rewarding one, I must say. So we're doing it again next month. Lip Lee is asking, "Hi, thank you all for the talk. The question is more for Dağhan and Manuel. I may be wrong, but it seems like most of your systems are built for plastic printing. With the accelerating research and printing in other materials such as concrete or steel, how future-proof are these print farms you have generated? Are they easily retrofitted to accommodate wireless additive manufacturing, for example?"
Yeah, I mean, from our side, we're a very small company, and we need to be kind of focused. So at the moment, strategically, we are not working with any other material. We don't really like calling them plastics. We prefer the term polymers because there's such a wide range. But we also use composites that are sometimes even stronger than metals, like carbon fiber filled and glass fiber filled engineering grade materials. But as I mentioned, only from a strategic perspective, we are restricted to polymers at the moment.
Manuel,
I think same here, right? Like you need to start from somewhere. Yeah. And I think plastic, that we are also quite a small company, and plastic is actually getting very interesting when it scales up. Like it's opening doors to like fight against other more well-known systems, like for example concrete printing. Like there is a reason why most experiments with concrete printing end up kind of questioning the necessity of being printed or not, and it has very limited flexibility. And not to criticize concrete, I love concrete and I've worked a lot with concrete, but I think the world of polymers is so vast, and our responsibility as makers, I think, is so huge in terms of the sustainability impact that we're having. That I think it would almost be a shame not to use a very natural material that connects perfectly with this technology to start investigating these notions of creating a more clean and sustainable production chain. And for that, right now plastic is a very good player in that sense. We're also investigating others, right? And we're creating also plastic formwork for cellulose, for concrete, for other materials. But we are really trying to push the power of plastics. Things, again, we're stuck with it forever anyway.
And I mean, from our experience as well, the pavilion that Dağhan was referring to, the part of it was printed in concrete, and I can safely say that there are a lot of challenges in that realm as well. So we've seen also the amazing example by MX3D of the steel printed bridge that was the design was changed multiple times, and it took a lot of time and funding to complete. So I'm sure that there were a lot of challenges that were encountered in that research project. Amazing piece of work, but still. There's a lot of work to be done. The last question, we've got 5 minutes left, and I'd like to address that question to Alistair. Ithar is asking, in your opinion, for cloud design submissions to be produced in a microfactory and then put together on site, how does such design allow for high customization of spaces? From my humble knowledge, most of my 3D printed architecture so far are modular and to some degree for reasons of structure of joints. I didn't read the second part of the question, but it seems like the first part is very well accommodated for Alistair to answer. So design submission, how much flexibility is allowed in the design process?
Yeah, I mean, obviously, there's actually a quite well-established field and understanding about the field of mass customization and how you create a spectrum of choices and limitations within a system. But the answer is really usually as much as you want. Mm-hmm. And that bit isn't actually difficult. Like, it's not that difficult. Like, so for example, we're using a CNC router, so it's a bit harder to do on panels. So it's a bit harder to do curvy shapes, but 95% of buildings that most people need do not have curves. So, as much as you might love curvy buildings, it's okay. Mm-hmm. So the answer is, yeah, it's like there's basically an hour-long answer to this, and there's like a 5-second answer, and the 5-second answer is it's really quite easy. The harder bit, as I said, is the communication piece. And the hardest piece of all, which I think, by the way, if I may sort of back a bit to this question, things like automation and education, right? A lot of that stuff, the answers are the same in the sense that, the main problem with architectural education today is that it's still like narrowly defined around this definition of what an architect did and what an architect's business model was, that was based in this previous kind of industrial era, and it's just not true anymore, right? There was, and people will, when you start innovating and stuff around like this other stuff, people say, "Well, that's not architecture." It's like, well, actually, if you strip back to the original foundation of why the profession of architecture was created, it does not mention drawings. Mm-hmm. It does not mention a particular business model. It does not say, "Oh, you should be making your money by selling drawings to rich people," right? What it actually says is you have a public duty to society in the built environment. Mm. So at that point, we have to start taking that's why these technological explorations are really important, and it should be architects leading that. It should be architecture education needs to be training us to think about those aspects and also the wider systems without getting hung up on a very particular definition of what an architect is going to do in their jobs, because they're definitely not. So an architects are in that automation chain as well. And what the other said is exactly right. Like, in a functioning society, every job that gets automated, it doesn't matter, because you use the production gains to reinvest those gains back into other areas of growth. The thing that's breaking in our society right now is that's not happening. Right? We have massively extractive economic systems of economic rent. If you Google the phrase economic rent on Wikipedia, it's basically when companies are extracting money for nothing. So we should be much less worried about automation and much more worried about the ownership of automation and the use of automation, particularly in the land economy. So right now, we can make a super efficient 3D printer that auto customizes and a robot goes and builds a building on a site with 0 laborers involved. But will it make better buildings? No, because real estate investors will buy that land. They'll get a robot to print the smallest, crappiest little box that they can, and then sell it for the most amount of money they can and produce no labor value in the meantime. And then they will hoard that money and offshore it, so they won't be paying any tax either, right? So it's the same technology, but a radically different use case. Again, same situation with customization in UBI. I can make, we've making a system whereby people can customize their own homes. But what we found is that most people, particularly in the UK, don't have the ability to buy a plot of land. So actually there's a broken system there. And actually part of that broken system, which I said, I just published a paper about it at the weekend, is, for example, people talk about universal basic income as a response. Oh, right. People talk about universal basic income as a response to automation, but it's based on the Luddite fallacy, the principle that all jobs will be gone. It's never happened. There are many, many things that still need doing in the future. In fact, we've got climate change to beat. We're not running out of jobs anytime soon. But the other thing is, if we introduce the universal basic income today of say $1,000, then next month the rents would just go up by $1,000, right? So unless we fix the underlying economic issues behind our built environment, we will not unleash the amazing potential of innovation and creativity within the built environment. So that's my big.
And that's a great note to end on. We're out of time, as you can hear from my alarm here, and it's perfect timing, actually. So thank you to our panelists. Alistair Parvin joining from London, and so is Manuel Jiménez García and Dağhan Çam. And thanks to our attendees joining from all over the world. The conversation was enriched with your presence and your questions. So thanks a lot, and hope to see you soon.